Meet Oumuamua, the strangest asteroid ever found, the visitor who fascinated astronomers and piqued our interest. Oumuamua's elongated shape, resembling a cigar or pancake, was first observed in 2017 by the University of Hawaii's PanSTARRS, one observatory. However, its riddles are far from over. Scientists are both perplexed and interested in this interstellar object, which has traveled millions of years from outside our solar system and exhibits acceleration that suggests a non-gravitational force is acting upon it. What was the interstellar object Oumuamua, and what is its current location and trajectory? Come explore one of the most bizarre discoveries in space with us in today's video, the mysterious asteroid known as Oumuamua. Keep watching to solve the riddles it contains. Astronomers accidentally discovered the object in October 2017 as it was traveling through the inner solar system on a slingshot trajectory that would send it hurtling back out into interstellar space. With only a few weeks to investigate Oumuamua before it vanished from view permanently, the quick flyby left more questions than answers. More than 7 years after the object was discovered, scientists are still having difficulty understanding the scant data they were able to gather, particularly those that showed Oumuamua was speeding away from the sun faster than gravity could account for. The item defied all expectations by somehow hitting the gas as it drove away, resembling a scared motorist leaving a sketchy area of town at high speed. The most popular ideas use either hydrogen or nitrogen ice sublimation. The theory that Oumuamua was a spaceship is unfounded. How come it is called Oumuamua? Its name, which means a messenger from afar arriving first in Hawaiian, is aptly appropriate for the first interstellar object found in our solar system. Because PanSTARRS 1, the telescope that made the discovery, is based in Hawaii, a Hawaiian name was chosen. At first, it was believed that Oumuamua, a planet in the Kuiper Belt, was a long cylinder with a size ratio of 10:1. Afterwards, though, scientists reshaped it into a pancake form that resembled the tiny planet Arakoth, which NASA's New Horizons mission had found. Oumuamua was likewise incredibly small, with measurements of 377 feet (115 meters) in length, 364 feet (111 meters) in width, and 62 feet (19 meters) in thickness based on its albedo of 0.1, which is about average for a cometary nucleus and indicates that it reflected 10% of the sunlight landing on it. Seligman told Space.com, "I have been trying to explain the outgassing for several years now. Initially, I reasoned that maybe there wasn't enough dust in the outgassing for the coma to form. Subsequently, we speculated that it might be composed of a material more volatile than the typical comet material, like carbon monoxide, nitrogen, or hydrogen. However, each of these explanations had theoretical flaws. For instance, for hydrogen to freeze into particles the size of Oumuamua, incredibly low temperatures would be needed, and Seligman said that scientists don't anticipate finding such temperatures inside the dense molecular clouds where these objects form. He continued, "The Milky Way does not contain enough nitrogen to support the predicted number of such bodies in the galaxy." Scientists Seligman and Bergner now suggest that the chemistry of Oumuamua might not be particularly unique. Rather, the object was affected by extrasolar processes that astronomers are unaware of based on their observations of comets in our solar system. A comet traveling through the interstellar medium is getting cooked by cosmic radiation, forming hydrogen as a result, Bergner stated. "Our thought was, if this was happening, could you trap it in the body so that when it entered the solar system and it was warmed up, it would outgas that hydrogen? Theoretically, the force of this outgassing hydrogen might account for the unusual acceleration of Oumuamua, according to the team's estimates. The scientists even discovered experimental experiments from more than 40 years ago that showed molecular hydrogen could be separated from water ice by high-energy particles like those found in cosmic rays, but it would remain trapped inside an ice block. Now let's explore the 10 unusual things about Oumuamua 1. It's not from around here, we know that. 1I/2017 U1, popularly referred to as Oumuamua, was traveling at a speed of 196,000 miles per hour, or 54 miles per second, or 87.3 kilometers per second, which is too fast for it to have come from within our solar system. In our solar system, comets and asteroids move more slowly, averaging 12 miles per second, 19 kilometers per second. To put it simply, Oumuamua is referred to as an interstellar vagabond. 2. We are unsure about its origin. Although its origin cannot be determined, Oumuamua reached our solar system from the general direction of the constellation Lyra. It is difficult to determine where Oumuamua was born because the stars were in a different position when they started to drift away from their original planetary system thousands of years ago. It may have spent billions of years traveling across space. 3. We are aware that it must go. Oumuamua is not coming back. She is departing from our solar system. It is traveling quickly in the direction of the constellation Pegasus. It will cross Neptune's orbit in about 4 years and traverse 1 light year in about 11,000 years. 4. We're not sure how it appears. It's far away and less than half a mile long, so all we can see of it with a telescope is a speck of light. However, its unique spin indicates that it's stretched like a cigar about 10 times longer than it is wide. It is no longer visible to us. The best estimates of how it might appear are those created by artists. 5. We are aware of the slight acceleration. We were able to see Oumuamua's astonishing acceleration thanks to a quick response observation program. There was a small deviation in the acceleration from previous estimates. According to Davide Finocchia of NASA's Jet Propulsion Laboratories Center for Near-Earth Object Studies, CNEOS, jets of gaseous material expelled from its surface are likely the cause of this additional subtle force on Oumuamua. This same kind of outgassing affects the motion of many comets in our solar system. 6. It is tumbling, as we know. The comet appears to be rotating on multiple axes based on the observed anomalous variations in its brightness. 7. We are unsure about its composition. When comets in our solar system approach the Sun, they release a lot of gas and dust, but Oumuamua does not, which is why some observers thought it might be an asteroid. Astronomer Karen Meech of the University of Hawaii's Institute of Astronomy speculated that during Oumuamua's protracted voyage across interstellar space, the microscopic dust grains that are typically present on comet surfaces may have worn away. The more we study Oumuamua, the more exciting it gets, she stated. It's hard to tell right now, but it might be releasing gases that are more difficult to notice than dust. 8. We were prepared for it. Not when, though. It has been decades since scientists predicted the finding of an interstellar object. There are undoubtedly billions and billions of asteroids and comets circling the cosmos on their own. Scientists realized that some of these tiny objects will eventually find their way into our solar system. Oumuamua's interstellar visit validates our ideas of planetary system formation. 9. We're not sure what it's doing right now. Even from space, Oumuamua was no longer visible to telescopes after January 2018. To solve more mysteries regarding this unusual interstellar visitor, scientists are currently analyzing the data gathered throughout the global observation campaign. 10. We are aware that the likelihood of seeing another one in the future is high. Because Oumuamua is the first interstellar object ever spotted in our solar system, scientists advise against making any broad assumptions about this recent